Hello and welcome again. Today, in our video lecture, we shall talk on measures of central tendency. If you are yet to watch the introductory lecture of our video series, please watch it now before this video. We are trying to understand statistics and genetics rather than learning and following it blindly. Measures of central tendency mean tendency of the data to cluster around a central point. It gives us a summary statistic that represents the whole data. It also helps to comprehend, summarize, and compare different data sets. As discussed in our previous lecture, three different averages exist, and today we shall talk about mathematical average in detail. Arithmetic mean is most commonly used mathematical average. It's also known as average or mean and is represented by x bar for sample mean and mu for population mean. Its calculation incorporates all values, and if a single value changes, the whole mean is bound to change. If x1, x2, x3, so on till xn are the observations, we sum them and divide with the number of observations, we will get mean. For frequency based data, the calculation is little different. Please pause the video and try to comprehend how mean is calculated. The example for calculation of mean for frequency based data is shown here. Combined mean. An interesting situation comes when we have means from different situations with different number of observations. How is the combined mean calculated? There is a formula. N1 M1 plus N2 M2 plus N3 M3 plus so on divided by N1 plus N2 plus N3 plus so on, where M1, M2, M3 are the means with N1, N2, N3 being the corresponding number of observations. How do the extreme values or the outliers affect mean? Here we use the same example as taken previously. We change a single value and mean changed considerably from 21.8 previously to 29.6. Please pause the video and let the concept sink in. The mean is changed by change of entries or values in a data set. Suppose we add or subtract a constant value from each entry of a data set. The mean will be increased or decreased by the same constant value. Similarly, if we multiply or divide each entry in data by a constant, mean will be multiplied or divided by the same constant. Coming to geometric mean. Geometric mean is used for quantitative data that follows a series pattern. Viral load, titer values, parasitic load, share market data are examples where geometric mean is useful. Geometric mean is actually nth root of product of n numbers. We have a series data here for which arithmetic mean is not a representative at all. However, geometric mean is a representative. If any of the entries in data is 0, the geometric mean automatically becomes 0 and thus meaningless. Harmonic mean is the reciprocal of the average of reciprocals. Too many reciprocals. reciprocal of a value means its inverse. If x1, x2, x3, so on till xn are the values, harmonic mean will be calculated as. There are 3 steps in calculation of harmonic mean. In step 1, we calculate the reciprocal of all entries in data. In step 2, we find the average of these reciprocals. In step 3, we calculate the reciprocal of average value. Friends, please pause the video and try to follow these steps in the given example. Harmonic mean is useful in rate type situations and is good for handling large outliers in the data. Please pause the video and try to follow the given examples. Merits of harmonic mean include it being rigidly defined and based on all observations. It is suitable for data with large dispersion and outliers. It gives less weight to large entries and vice versa. However, it is difficult to calculate, not so popular, and usually this value does not exist in the dataset. Friends, to conclude, there is a relationship between 3 types of mathematical average that we have dealt in this video lecture. Arithmetic mean is always equal or greater than the geometric mean, which is in turn always equal or greater than the harmonic mean.